So I'm Antoine Sabot-Durand. I'm working at Red Hat. I'm senior software developer at Red Hat. I've been an architect and tech consultant for 16, 17 years now. And I've been working in different open source projects in the last year. And right now I'm working on CDI. I'm co-speccing on the CDI specification, one of the Java EE specification. I also have a role in the animation of CDI community development, trying to gather all the initiative around CDI. And I'm also technical leader on a small framework called Agorava, which is a framework related to social network and social media based on CDI. If you want to follow me on Twitter, is my account. So, what are we going to talk? I'm going to go in a fast way through Java EE, because if you attend the previous talk, you learn a lot about Java EE and Java EE 7. I will talk to you about the application server from Red Hat, from JBoss, the famous WildFly, which is about to be released in coming weeks. And after that, we will go straight into the code and see a live example of coding in Java EE 7. So, I will go fast in this part, in history part. So Java EE is a long story. It starts about 15 years ago with the first version that was Java Professional Edition. And there was a lot of version in a short amount of time until the J2EE 1.4 that stay a lot in usage and encounter a lot of critics, and that led to creation of new framework like Spring or Hibernate and things like that. So there were a lot of time between J2EE 1.4 and Java EE 5, so the name changed between both of them, because there was a lot of self-critique inside the GCP, and people tried to take inspiration from the new framework that were created to introduce those things in the Java EE specification. So that's the reason why we got in Java EE 5 new things like GPA, like convention over configuration, like light EGB and things like that. And now we are 2 iterations later. So there was the Java EE 6 in 2009 that introduced the famous CDI, my baby. And the last one that we are talking about right now, Java EE 7. So I won't go back on the main feature. You saw them sooner in the previous talk. So it's the same. So it's a different way to present all the GSR of Java EE 7. In my talk right now, I will deal with some of them, not all of them, because we don't have all the day to deal with them. We will talk about WebSocket. So I will start with a basic example with WebSocket, and we will build on this example. We will deal with JSON, with GSF, CDI, of course, all the Interceptor and GTA 1.2 part, a little bit of GPA, and if we have time, we will finish with JMS and message-driven bin in AGB. So I will talk you about WildFly, because we have a lot of presentation about Glassfish previously, which is okay, which is a nice application server. So we start building a new application server last year before the release of Java E7. So the new name of the JBoss application server is now JBoss WildFly. The name changing is due to differentiate the community version, which is the JBoss WildFly version, from the JBoss application server EAP, Enterprise Application Platform. And you can see that the same way that we release Red Hat Enterprise Linux and Fedora. That's the same difference. So there are two names to avoid confusion. So this version supports Java E7. It's quite lightweight and quite fast. We will see how fast is it later. And of course, it's open source. Speaking about the roadmap, so there were a lot of releases to gather feedback from users, from developers on WildFly. So the first release were alpha release. They were released before Java E7 released. And right now, we are on this candidate release 1 of WildFly. And normally, if everything is OK, the final release should be around March or April of this year. So it would be released before 1 year of Java E7, which is better than the previous release of JBoss I7, which were released, I think, nearly 2 years after the release of E6. So I will demonstrate WildFly during all the presentation. But if you want to play, you can download it today on wildfly.org and play with it. So enough with introduction. Let's get some action. So we will start with we will build the presentation on the use case. The use case is that you're working at a new startup called Chat-E-Chat-O, and this startup wants to build a software as a service chat service. So we gone to see VC and raised fund, and now we decided to use Java E7 to build our main product. And we want to give a try to Java E7 to see if it can comply to our needs. So we start with the beginning. So the first version, the first release, is a very simple chat client and server that can demonstrate one of the first specification of Java E7, which is the WebSocket specification. So we can start the application with 4 files. So using the Maven build system, we will have the pom.xml, so all the build specification. We will have one Java class, chat endpoint, which will be quite similar than the chat endpoint that David showed in his talk previously. We'll have an HTML page and a JS file to deal with WebSocket Exchange. I think it's better to show you code directly. So if you want to play with all these examples, they exist in real life. So you can go to JIT and make a checkout. And all the steps in my presentation are a branch in the repository. So, I think it's better to show you in live. Okay, let's start with the Maven file. There are people that are not familiar with Maven here? No, everyone uses it every day, okay. Everyone suffers every day, so. Okay, so my Maven file is quite simple. I have only one dependency. It's a dependency on the Java EE7 API. And I use a few plugins to make my project works. First plugin is the compile plugin to tell Maven to use Java 7 to compile the code. Another plugin is the WAR plugin to configure the fact that we are going to build a web application, so a WAR, and we should avoid an error and a failing error because there won't be any web.xml in our project. So now we can build, in EE7 we can build a project without web.xml. And the last plugin is a plugin that allows us to run WildFly directly. So if you use this example, you won't need to download WildFly. You can run it directly from the command line. It will download all dependency and WildFly engine from a Maven repository. I will show you that right after that. You can also download WildFly and configure your IDE to use it. So here I use IntelliJ, but you can use Eclipse, you can use NetBeans, whatever. The other files. So I have my class, chat on point. So it's quite similar. It's very small piece of code. So what I have in this piece of code is some annotation related to the WebSocket specification. So I define the fact that this class is a server endpoint. I have the method regarding the creation of a new connection, the method regarding the closing of the connection, and the method, the famous onMessage annotated method that will deal with a new message. So what this class will do, it will keep a list, a set of all the people connected, all the sessions connected to the server. When someone asks for a new connection, it will add this connection to this set. And when a message is received, there will be a loop across all these elements, and we will broadcast the message to each peer. So it's quite simple. Oops, unzoom. So on the HTML part, there is nothing very special to deal with. It's only a little page, quite ugly page, as we will see, that will show a list of people logged and a chat log to see all the messages that were exchanged. By the way, this example was taken from Arun Gupta when he demonstrates the WebSocket specification, and after that I added things on it. And the last file is the WebSocket.js, so the JavaScript part, the client part of the WebSocket. I'm not a JavaScript specialist, so I won't go too much into detail, but we can check what is done in this JavaScript part. So we have the function to join the WebSocket. So we use the WebSocket that was created at the beginning of the script here. You see the code? Okay. And we send a message telling, OK, username joined the WebSocket. We have a function to send a message. So we take the content of the text field and we send it in the WebSocket. And we have a method that is called on the event of a message received, and that take this message and regarding this content, use it as the fact that a new user has connected, if there is join in it, or the fact that it's a normal chat message. So nothing very fancy. The registering of the event is done here. Okay, and that's it. Don't ask too many questions about JavaScript, please. You can do it on the code and things like that, not JavaScript. So let's see what it does. I'm not in the right directory. Okay, that's it. So I'm in the directory of my project. I have my pom.xml. So normally, if everything goes right, I can use the WildFly plugin and ask the WildFly server to run. So I need a connection to the internet, and that doesn't work. It's perfect.
That was a spelling mistake.
WildFly. Yeah. Thank you. Okay, so he built the project, downloaded all the WildFly stuff, and start the server. Normally, it should work. I said normally because as every person that give a talk, I make some change during the previous talk. So normally on localhost here. Okay. So here's my application. I refresh to check. So what I've got here is my HTML page. Here I will have the list of the user connected to the chat room. I will have the chat log here, and I can use, and I have a log window here to see all the event that happens on the server, on the client. So I can say, for instance, I'm Antoine. I want to join, so I'm here, and I can chat. Okay. That's perfect. So to see that I'm not alone in the world, I can start a new server, a new client. Oops, too fast. Okay, so I see that Duke has connected here. So in the perfect world, I should have done things here on the connection to gather all the persons that were connected before, and I can tell it here. Okay, here and there. And there. Okay? Wow, it's magic with this little amount of code. Perfect. It's ugly, but it's magic. So that's our first step. Now we want to add functionality in our chat service. So we have to add few things. So here, continue here. So we saw all this file already. Okay. And now that what we want to do is to be able to have some partner on our platform. One of our partner is a very powerful company which is called Poodle. Poodle has a search engine, very famous search engine, and they want to use our service and embed our service, but they need to have a solution to detect keywords because they have an advertising platform on their search engine. So we have to show them that we can have a system, we can plug a system to detect keyword in the chat and to trigger some things when some keywords are entered in the chat. So we decide to build a prototype to show them that we can do that, and we will use CDI and CDI built-in observers to use these to show that we can trap and trigger those things. So to do so, we will have to activate CDI in our application. We will have to modify our class, the chat endpoint class, by injecting an event generator in the endpoint, and to change the message method to trigger to fire an event, a CDI event. And after that, create an observer of the event that will do whatever to broadcast the event to Poodle. Okay, let's see that. So if you play with the code, you can check out the first step. So if I was courageous, I will write all the code in live, but I'm a pussy, so I'm going to check out the code instead. So I'm changing the branch, and I'm stopping the server because I think it won't like to have the code change and running at the same time. So first thing to do is to activate CDI. So CDI can be activated only by adding a file in the application. So you have to add a beans.xml file to tell the server that this application will use CDI. When you do that, CDI is activated for the application. That means that all the class that can become beans will become a bean. So all the projo that are not abstract, that have a default constructor with no parameters, or a constructor with parameters and annotated inject will become bean. So it's automatically done. It's the magic part of CDI. In CDI 1.1, so in Java E7, you can prevent beans, a class to become beans with some annotation. So by doing this, my chat endpoint will become a CDI bean at the same time as it is already a WebSocket endpoint. So what are the changes I will have to do in my endpoint? I will have to inject what is called an event generator in CDI. So here, the @inject is the way we inject beans in CDI or from CDI. So here, I inject an event. The type of the event is string. I could have put whatever type I want. If I wanted to have more personal structure to exchange event, I could have built my own class for the event. And I will use this event generator in my own message method. So I will check in my own message method if my message contains the word world, I will fire the message. So I will be able to detect the word world. That's hard to say. The word world in the chat. Okay, that's the first part. And at the other end, I need something, some kind of service that will be able to listen to this message. So I will create a new class, a message observer, and this message observer will listen to the event. So here I have a method with the parameter annotated at observes, which is an annotation, a CDI annotation, telling this method listen to the event of this type. So event of type string. If I have used my own kind of type, I will have to put the right type here. Okay, and this listener will only display something in the console with a keyword was trapped here and give the message. Okay, so as I'm a bit lazy, I will launch the server from here. Okay, launch the server. So I had the same application that sooner, but here normally if I enter something like hello world, there is world in it, and in my console I should cross finger. Okay, here. Oops, keyword was trapped here. Hello world. Okay, and if I enter something else, I don't know. Nothing here, okay? So a very basic usage of CDI and CDI event, which is a pattern observer implementation. Okay, that's our first simple step. So if I go through the slide here, okay, so we added the bins XML. We modified the chat endpoint to add the event generator, and we used this event generator in our code. And we added a bin with an observer. So we created a way to decouple the logic of trapping from the logic of managing the fact that this event was triggered. Okay. So let's try to get further. Okay, we have a system that can detect certain keyword, and it's worked quite nicely. But we are not very happy with that, because we are thinking about over request from our client or partner, and if we keep that way, we will have issue in our development, because we will have a message method with all cascading if and doing a test in every corner to trigger event and things like that. So what we would like to do is to use AOP and use the Interceptor to have this filtering part outside of our business part. So what we are going to do is to add which is called a qualifier to distinguish add word from overstring event, to have a way to to tell this event is for our partner Poodle and not for another partner. So we can support other kind of filtering and event triggering. And after that, we will create an interceptor specific for the AdWord filtering. And we will add this interceptor in the chat endpoint message method. Okay, so I will check out my next branch, second step. So in this step, I will add a qualifier. So what is a qualifier? The qualifier is a notion in CDI that allows to distinguish two injection points with the same type. I was a bit fast on CDI, but the idea on CDI and dependency injection in CDI is based on strong typing. So I don't inject a bin with an ID or things like that, and I inject a bin with a type. So sometimes I will need to inject two bins of the same type and have some kind of solution to avoid ambiguity between the injection if I have two bins with the same type. So I will use qualifier to qualify my injection and say, okay, this bin is of the type, I don't know, here I have a string message of type string, but it has the qualifier here, qualifier AdWord. So what is a qualifier? It's an annotation bearing the meta annotation at qualifier. Okay, I think we will see how it is used. It will be clearer. So, if I take my chat endpoint right now, I don't have the injection of the event generator I used to have before. You remember, I have the inject event string, etc. Because I will use this event generator in my interceptor. My message method went back to the first version, so there is no if and things like that in it. But I added an annotation on it. At Poodle filter annotation. This annotation is an interceptor annotation. And I defined it like this. So I created this annotation here. Oops, try to zoom off. Okay. So this annotation was defined like any annotation, but I added on this annotation a meta annotation. So the @interceptor binding annotation, which is part of the interceptor specification, telling that this annotation will be used to intercept the treatments, so to add AOP, aspect-oriented programming on the treatment. So it can be added on a method, or it can be added on a whole class to add the treatment. And after that, I have to create my interceptor. So my interceptor is created like that. So I define a class. I'm going to close this, it's not useful. And perhaps it will be better in, okay. So I create a class, standard class. There is no interface or to implement or abstract class to extend. And I will add on this class the @interceptor annotation to tell this class is an interceptor. And I added to the class as well the interceptor binding annotation I defined before to tell the server that this class should be called when we ask for the Poodle filter interceptor. It's the Poodle filter interceptor. Okay, So in my class, what I have defined a list. I have defined a dictionary, a list of my AdWords. So I have world, duck, Cartman. Here I have injected my event triggering, the one that was injected in my WebSocket endpoint before. So I do it here now. And I have my specific intercepting method definition. So it's here. It's annotated at around invoke to say, okay, this is the method we should call when the method that were annotated with the poodle filter is called. So if before going into that, I will go back to, oops, I will go back to my chat endpoint, and we will go that. So when this method is called, the system sees that there is an interceptor defined on it, the poodle filter. So it doesn't execute the method. Instead, it calls the method defined in the interceptor with the @around invoke. So here, when the message is called, we won't execute this code. We will execute this code instead. So in this code, I have got a context that is automatically built and sent by the system. So it's my invocation context. And in this context, I know what should have been called, and I will be able to do things with that. So what I do in this interceptor, I'm reading the parameter that were sent to the method that was called. So if we remember the message method, there is one parameter, which is a string, which is a message. So I get the message here. So it's the first parameter of the method. To build my match, I create a lowercase version of the message, and after that, I have a loop in my dictionary, and I see if in the message I have one AdWord, and if I have one of these AdWords, I fire the event. And after that, I can call the ctx proceed. ctx proceed called the context that was kept away of executing, and the fact that the managed transaction was called instead of the original code. Sorry, it's not very clear. So I call the final method, the message method here. So what can be done in this interceptor? I can do something before calling the final method. I can do something after calling the final method. Here I don't do nothing after, but I could have. And I can do something instead of calling the final method. I can totally ignore the final method. And I think it's, yeah, and I have a static, I have a method to call the dictionary, but it's not very interesting.
How do you know that this is before?
Because this code is called instead of calling the method, the message method, okay? It's called instead, and but in the call, I've got the context, and in this context, sorry, I have the fact that the method that should have been called is this method, is the message method. But it's to you to decide what you have to do with this call. So I do a lot of things here to check things and this. And here, when I call the return, when I call the setX proceed, I tell the context, okay, now you can proceed the method. I could have done the setX proceed before, and I could have avoided doing it. And I could have done something after the setX proceed. Of course, I shouldn't have put a return here, but I could call setX proceed and, I don't know, do something if the proceed had an error or things like that. That's the way we are dealing with transaction in Java EE, for instance. When you have transactional behavior in AGB, and now with the @transactional annotation we will see later, that's exactly what is called. There is a transaction management method, and you can see with the name of my method here that I copy-paste code from transaction management. In this way of doing things, when I have the @transactional annotation, I go in the interceptor. The interceptor starts the transaction, call the final code, so call the setX proceed, and after that close the transaction. Yet here we are doing something far more powerful than that transaction. It's very important. Okay, let's check. How does this work? So my add word are world, duck, and Cartman. Okay. So I John. Okay, and I here. Okay. Add word trapped here. And to show that it works with all the, okay, that's it. So I didn't have to put some kind of XML configuration in the way. I have only annotation, and I activate or inactivate the interception in the code. There is another mechanism in CDI for doing aspect-oriented programming, which is called decorator. It's another way to do things. I won't show it here because there are some kind of issue with decorator on a chat on punch, but you have a more business way of doing interception, but it's very similar in the way of working. What I wanted to show you now is the way we can put priority in the interception. If you see here, I have an @priority annotation I didn't talk about before, but it's the way that we can sort all the interception in the application. So we can have multiple interception on the same part of the code and decide the order of the interception. That's what we will see in the next step. If you have questions, don't hesitate. So, if I go through all that we have seen right now, so we have created the add word qualifier. By the way, I will show you where is it used. The add word qualifier is not important for the interception. It's to be ready to accept other partner for an interception and have different kind of events with the same type, with the string type, and be able to differentiate them. We will see that in the next step. So I have this qualifier. I create my interceptor binding. So with the annotation and the meta annotation interceptor binding. I create my interceptor and added the interceptor binding in the annotation list on the interceptor. And yeah, that's what I didn't show. And I applied the interceptor to the chat endpoint and change my observer to support the qualifier in my event. Perhaps I should show you more on that. The previous version of my observer was only observing, string. You remember? So I had an @observe string word. Now I added @observe @addWord string. The difference is that here I won't observe event of type string if those events are not qualified with the addWord qualifier. That's why here I was a bit too fast on that. Here, what I inject is not inject of event string, it's inject addWord event string. So my generator will only generate event with the qualifier addWord. Okay, so if I have another event generator somewhere else throwing event of type string, and if these events are not qualified with addWord, my observer won't be triggered. We will see that in the next step. Okay, so let's do it. Oops. Okay, my next step. So I shown my partner Poodle that I can trap AdWords and do things if I wanted to do things with these AdWords. Now I have another company that is interested by working with my very nice chat solution. It's the Maple company. They want to use their chat solution, but they have a very strict policy regarding bad words. So it's very important for them to avoid all the bad words. So they need a solution to catch those bad words and replace them by good words because they think they have the good taste. As we have a very lucrative partnership with Poodle, we want to give them the priority on the AdWords before correcting the bad words. So we have AdWords and bad words. So they should be triggered before we change the content of the chat message. So we will have to create the same kind of things that we created before. We will have to create an interceptor and a filter to change the content of the message. But we will have to use priority in interceptor to be sure that the Poodle filter is launched before the Maple filter. So how we will do that? So first we will add the bad words qualifier, and here it will be useful because we will have two kind of event that will be fired. There will be event for our first partner Poodle, and there will be event for our second partner Maple. So we will have to differentiate them. That's the reason why we have another qualifier, and we will use this qualifier later. We still have our Poodle filter interceptor. That doesn't change. Okay, that's the same. We added a Maple filter interceptor binding. That's the same as the Poodle, but it's not the same name. Our chat endpoint is quite the same. The difference is here. We added both interceptor binding annotation on the message method. So that says that when we call the message method, we shouldn't call it directly, but first one interceptor, and after that, the second one. Here, the order of the annotation is not the order of the interception, because in the code it's not that way that it is used. We're gonna define the order here. So here, we still have our Poodle filter interceptor, so it's the same that we saw previously. Remember here we have a priority, okay? And we created another interceptor binding. It's the maple filter interceptor here. So I will go in the code right after that, but what is important here is to see the priority. So we take the priority at application level, and we added 10 to this priority. So it's a higher number, so it's a lower priority. It's the inverse. So this filter will be executed after the one. It's higher in level, so it will be called after the Poodle interceptor. So here we have a dictionary. Here in this dictionary we have a map associating the bad words and the right words we should put in place of the bad words. I'll let you read. I inject an event generator with the qualifier bad words. So the event I will trigger here will be qualified with the bad word qualifier. And I've got my around invoke method here. What does this method? It will get the message, so it's the same. We will have the lowercase version of the message, and we will loop in the message and check if we have some kind of bad word in the message. If it's the case, we will replace the bad words from the good to the good words. So if we catch crap, we will put trap. If we catch Cartman, we will put Stan. Okay. Here we change the parameters of the call. So we have the context of the call, of the method message that was called. In this context, we have the parameters of the call, and we change the parameters. And after that, we launch an event to tell the system that we catch a bad word, because we want to replace and we want to notify that we replaced something, that this user had been naughty and sent bad word in the system. And after that, we proceed the system, the call. So if I test this code, okay. I don't know if I enter world. So world is still an add word. So it was trapped by, I didn't show you the observer. Sorry. In the observer, I have one more observer right now. I have the observer for Poodle with the add words, and I have the observer for the bad words as well. And the difference here is that one is annotated with add words and one is annotated with bad words. That's the qualifier. Why I have to do this? Because here I have the same type. Okay. If I have created, I don't know, specific classes to add meta information, I didn't have to do that. I wouldn't have to do that. So I have two kinds of message: add word trapped, that's what I see here, and bad word trapped. Okay. So here I enter only an add word. If I check my maple filter, Okay, I will. Okay, so this service looks like crap, and I have an automatic polite correction. This service looks like trap. And here I have a bad word that was trapped, for instance, and someone say crap. That's not very nice. And I have one, as a sample, I have one bad word which is also an ad word. So Cartman is a bad word, and if I go in my Poodle filter, Cartman is also an ad word. So what will happen if I enter Cartman in the system? So in the final message, I have Stan, but if I go in the console, I will see that the ad word Cartman was trapped, and it was also trapped as a bad word, but I didn't avoid the first content. I have the inverse, I have the opposite, if I remember. So here, I have the bad words idiots that should be translated to world in polite way. And here, world is one of my ad words. So if I enter idiots, oops, idiots with O. Okay. So the final message is you world. So stay polite. But as my polite correction happens after the AdWords filter, the Poodle filter, I don't have a message regarding world. Okay, so I see that both interceptors are triggered in the way I wanted to. I intended to have them. Do you have question on that? Okay, perfect. So here we saw a bit of CDI, a bit of the interceptor specification that is used mainly by CDI and under the scene that is used by EGB as well. And now I will go in over specification because we took a lot of time on that. But CDI is a very interesting part of Java EE, so I think.
Do you have a question on that one? When you use these interceptors, how much is CDI and how much is basic Java SE?
Java SE?
Yeah, I mean that you can annotate that's SE, but how much is done by CDI and how much is done by the JVM itself?
Okay, so the mechanism that is used, the question was about the parts of Java AC in the interception. Is that correct? Yeah. Okay, so the mechanism today that is used in interception use what is called a proxy. So we create a class around the bin, and in this proxy we manage all the calls in interception and things like that. So it's based on Java SE. So there is a bin manager, a container with all the bin, but it's done automatically. You could do this in Java SE, but you should build it by hand from scratch. I don't know if it answers your question. I can give you another answer. You can use CDI in Java SE today. So you don't have to be in Java EE to use CDI. The reference implementation, which is Weld, and the other big one, which is Open Web Beans, can be bootstrapped from Java SE. So you can have a CDI container in Java SE. And in this container, we will have all the things we just saw regarding interception.
Call it
Open Web Beans. It's an Apache project. In fact, there are three implementation of CDI. There is the reference implementation, which is the Red Hat one called Weld, the Apache Open Web Beans, and the last one is in the Gaucho server, and it is called Candy. But I don't think there is CDI 1.1 plan for Candy right now. So there is two major implementation for Java EE 7, the reference one, and the Open Web Beans for CDI 1.1 will be released in the coming month.
It was one of my more tricky questions would be, if you want to run this as a unit test, what would you do then?
Okay, if you want to run this as unit test, you have a lot of solution framework to run this. One of the solutions that is used by us, Red Hat, is using a framework called Archillian that can bring you a way of building all the Java EE environment to have all the behavior needed to do your test. Because it's not a unit test you do there. If you want to test the behavior of that, you have to do an integration test. You have to have all the magic activated. So you have to have all the things around that. But the solution like Archillian is quite nice to do that, because you can restrict the things only to the class you want to test. Okay. So you saw that, we saw that. Okay, let's do a little bit of GSF. Oh yes. We have a very ugly UI today. I won't promise you it will be magnificent after this step, but it will be a bit better. What we'll do is to use JSF for our front. Out of the box, JSF doesn't provide rich component. I won't say like that. It doesn't provide a way of giving a nice look to your application. It adds a lot of things, but it doesn't do that. But there are frameworks out there that add rich components by the looking using library like jQuery or Bootstrap or things like that. What we're going to use on that in the step is the Prime Faces project to give a clean look to our application. So how we will do that? First, we will add Prime Faces to our dependency list in our Maven configuration file. After that, we will change the HTML page and build a GSF page instead. So I will go in this GSF page after that. I will show you the list of the file before. I will have to slightly modify Websocket because in GSF there are some kind of ID generation in the HTML component that can be quite cumbersome. So I have to change those ID. You see there, I have a chat user field, chat log field, etc. Before this element were with the simple ID, user field, chat log field, etc., etc. So I have slightly things to change. And my index.html, I have to put a redirection to my index.gsf. Okay. So we're going to check. So the big part is the GSF page. Okay, so my code doesn't change. It's only the GSF page and the GS file that change. So if I take GSF page, what have I in this page? So it's very near from HTML, but there are things slightly different. I have to define some namespace regarding the library I will use. So here I have the standard GSF namespace. I have the parentheses namespace here. I will have some part that looks like HTML, but if here I define my HTML header, and here I define my HTML body. And now I have some rich elements that I can use to have a nice layout in my application. So here I use the parentheses layout component, which is here. And in this layout, I define different parts of the layout. As my design is very simple, I will have only a center layout to have a simple design. And if this center layout unit, I will put my input text I had before, my button. In my button will call the JavaScript call like it was done before. And that's it. And I added my JavaScript inclusion here. If I go to the JavaScript file, the only change, as I told before, are here. So I changed the ID of the element because GSF will generate specific ID of my element. So for instance, if we take user field, I go to the, oops. So user field is here, okay? So its ID is user field, but this user field is in GSF form with ID chat, so all the ID are built with the container of the component. So the final ID of my input text will be chat user field. So I have to change my code for that. Could be cumbersome. And that's it. So I can launch my. It's already running. I think I kill it. Perfect. Okay. Okay. Okay, of course, finger, it's work. So I won't say it's very, it's magnificent, but you have something more cleaner in the look of your application. So I won't go any further in GSF because we can spend all the day on it, and it's not the purpose of the talk. But you can see that quite easily, if you don't have deep knowledge in HTML5 or JS framework, you can have a clean look with very few things to add to your application. Okay. Okay. So we still have 20 minutes to go. Perfect. So now we have a nice, very nice application, beautiful application. Now, what we like to do is to have more structured message. until now we have a message in raw string format, and what we will have to get is use the JSON format to work with our message. So what we would need is to, instead of sending raw string from the JavaScript, we would like to send a JSON payload from the JavaScript to have information like the username and message and things like that. So for that, we will need to change the JavaScript. We will need on the server side to create a class to host the message and to change our endpoint to deserialize the JSON message. And for that, we will use the new JSONP specification in Java EE 7. Okay, so it's fifth step already. So in the JavaScript, what we will do is to use native call to JSON support in JavaScript. So we'll have to change the send message function and the onMessage function. So in the send message, instead of sending the message like it was sent without any modification, we will transform the message in JSON and send it with the JSON.stringify of the message. I'm a bit fast on that. In fact, we create a JavaScript object. In this object, we add a field user with the username in the form. We will add the message content with the text field value, and after that, we will create the JSON version of the object we created. I'm a bit in a hurry on that. On the message, the onMessage event, so we will get the event that will contain the message, but now this message will be in JSON format. So there will be two cases. The first one is the message linked to a new user joining the chat room. So this message won't be in JSON format, or a standard message. In this case, it will be a message in JSON format. So we will have to parse this message and recreate the message JavaScript object from the JSON received. Is it clear? Okay. On the server side, I will have to create a standard POJO to host our message. Nothing to say to that. And we will have to modify our chat endpoint. So now we have to do things to read and write JSON in our endpoint. So what we are going to do is to call a reader. I will detail that on the code later, because it's easier to show you with the cursor. So check out the fifth step. Okay. Maybe easier. So here, my endpoint stays the same except for the message method. So in this method, I will create a JSON reader. I will create it from the message I received. So the first thing I will try to perform some task on the message. If it fails, if I have an exception, I will only log on the console that my message is not in a JSON format. That can happen because my join my join message is not in JSON format. And after that, I will send the message to all the peers like it was done before. By the way, you can see that we still have the interceptor defined here. So what is done in the try clause? So we will try to read the object from the reader, and we will have, if everything goes well, JSON object to crawl through all the JSON tree to do things. If it doesn't fail, we have to create a new message object from the message class, and we will set the user field of the message and the content field of the message from the user and content field of the JSON object we initialized here. Okay. After that, we can add things in the console, and everything goes well. So I will send to my other connected user a JSON payload, and the JavaScript on the client part will parse this JSON. I can go back again to the JavaScript part. Okay, if I go there. So here, when I receive a message, yeah, that's it. When I receive the message, if there is a join in the message, it's not a chat message, but a joining message. And if else, it will be a JSON, so I will parse it. And I will add to my chat log, so it's the part with the log in the lower part of my screen. I will add the message content and the SAID and the name of the user. Okay, that's it. So you can see that the join function here doesn't do anything with JSON, so it stays in plain text, and here in the send message. On the other way, it uses JSON to transform the message in JSON format. So let's check what it does. Still running, not a good idea. Okay. So if now I click on the join, here I will have my my exception, because the message that was received is not a JSON message. Normally, it's normal because it's a joining message. But now if I send an, I should change this message, hello world, every time. Okay. That's not the same. So what was received is user Duke and content hello world. So I have a JSON structure, and I can write in the console message from user. Here is the message. Okay. And that's it. And here in my chat log, instead of writing user and message, I can distinguish both parts and write hello world said user. That's what was done in the JavaScript here. My message said and my user. So I have more structured message across my application. So as David said in his presentation, right now the JSONP specification is only for processing. We don't have a JSONB for binding. So here, what I do in my example is more binding because I have to parse to fill the field in the message class. We could use another framework to do that. It was to show you how easy it was to parse JSON with Java E7. Still 2 steps to go. I don't think we will be able to see both of them. Next step is about GPA. I won't show you new things about GPA in my presentation, so I will go a bit fast on that. The idea is to tell now we have structure message, so we can save them to a database. What I can show you in this part is the fact that we can have transaction in our CDI class. And we can do transaction without using EGB, what was mandatory before Java E7. So now you can avoid using EGB if you don't need EGB specific things that are still useful, like asynchronous treatment or multi-threading or things like that. If you only need transactional stuff, you can use it directly in CDI. I will show that right now. So to have a persistence activated in my project, what I will need is to define a persistence.xml file. I will use the default data source integrated in the WildFly server. I could have built a full data source in my example, but here the example DS is integrated in the server, so because it's not the case. Here I use specific int of GPA int to deal with database creation and things like that. In GPA 2.1, there are standard things to generate the database, but it doesn't work with every database. That's the case with H2. That doesn't work. So I have to use the Hibernate specific things. So it's not very interesting in the Java E7 perspective. What is interesting is 2 things. The first things. 3 things. The first thing is the way we can use CDI to get the persistence context and re-expose it as CDI bin. The idea is to have my entity manager, my GPA entity manager, having the same behavior as the CDI bin. So you can add specific CDI stuff in it, like interception and things like that. It's also a good solution to use this kind of. I use a Java resource and I re-expose it as CDI. If you're working with things that are not directly accessible in CDI, like remote GB and things like that. So it's a pattern that can be useful. So here, no, not here. So I added a message service here to deal with the entity manager. I inject the entity manager here, and I have a very small method here to persist my my message. What is important here is the add transactional here. It's a new stuff in Java E7. So all the transaction and GTA stuff before Java E7 was very easy to use and automatic to use through EGB, and for other service it was quite cumbersome to use them. Now with the fact that the GTA integrate the add transactional interception, you can use the transaction in CDI. So the fact that you added the add transactional here, which is an interceptor, by the way, will open a transaction before calling every method here, do the method, and close the transaction after the treatment. Very convenient. And the last thing that can be interesting here, I don't know what is, okay, I have the last minute bug. A file that doesn't want to open. Okay, that's not important, that's not grave, I will see. Yeah, here. So my message.java class could be modified should be modified to support the GPA annotation. I won't go very deep in that. The important part in the Java E7 perspective is the @vetoid annotation you can see on the top of the class. It is recommended that GPA entity won't be take for CDI bin, because GPA entity have the very specific life cycle. They are created by the entity manager, destroyed by it, and CDI has its own life cycle. So, except for very specific situation, you should avoid to have CDI manage the entity. The @vetoid annotation is a way now to tell, okay, this class could be a bin, but CDI won't take it as a bin because it's not CDI job to manage the bin. Okay, that's what I just saw. So here, that can be interesting. So I created a service to manage the entity manager and persist error message. If I take my chat endpoint, here I inject this service here. Quite normal. And here I use the service. Here I use the service and I call the persist message of the service to write to the database. Okay. We can check that this is working, and we will finish on that. You see here in the console, in the log, you can see all the stuff about creating the table and things like that here. And we will see the request done in the database when the message will be saved. So I join chat. Okay, and here you see I have my usual console system out stuff, and now I have the insert that has been done in the database. So it has been very easy to activate this and have a test environment for my persistence. And I think we will finish on that. I won't have time to show you JMS. But you can check the presentation that will be on the SlideShare or speaker deck to earn by yourself. Do you have any question to finish? Or too many questions? Yeah?
Just the exact name of the unit testing framework?
It's called Archelian. I can show you the website. The idea is to have a solution that will create the in fact, the WAR you needed to test and launch the test and give you the results. Before that, what you needed to do is to go through all the build cycle, generate the final artifact, and after that, do your test. And if the test fails, you have created something, but it's not something that can be used. So you are outside the build cycle to do the test. With Arclian, all the test happens during the build cycle. So you can decide, okay, that failed, so I won't build the final artifact. And there are a lot of modules for Arclian, so you can have test, I don't know, for your UI and things like that. You can plug things to navigate on your application, your website, and have information and things. It's very powerful. Another question? No. I have one question. How many of you already use Java EE? Wow, Java EE 6? Wow, okay. And Spring? Not too many, okay. Okay, thank you.